Hello and welcome to today's lesson. Today, as you can see, we are going to cover two things here at once. We are going to review the Pythagorean theorem, and then we are also going to look at how to simplify radicals. So our objectives for today are that you can solve problems using the Pythagorean theorem and identify right triangles, as well as simplifying radicals involving products and quotients. Okay, if you do not have a notes page, either the printout or your notebook to take notes, please make sure you do that. Make sure you have a place to take notes. So let's take a look here. Pythagorean theorem. If you did not remember, our formula is down there on the bottom. A squared plus b squared equals c squared. So in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So a couple of things to note. Formula, super important. Another thing to recognize, Pythagorean theorem has a right triangle. You can only use Pythagorean theorem for a right triangle. You do need to also note that side C is always across from the right angle. Side C, the hypotenuse, is always across from the right angle. And then A and B, it does not matter which is which, but those are your two legs. Another thing to point out and to recognize is that side C is always the longest side of your triangle, so just kind of keep that in mind as well. So as we take a look here, a squared plus b squared equals c squared. The tiles are squares with 6-inch sides. What is the length of the hypotenuse of the triangle shown? So I see my right angle down here, which means across from that is side C. So I've got a squared plus b squared equals c squared. My legs are both the same, so I've got 6 squared plus 6 squared equals c squared. 36 plus 36 equals c squared. 72 equals c squared, and the square root then of both sides to get the c by itself and get the length of the hypotenuse is 8.49. In my calculator it does say 8.485 and then continues on because it's irrational or not a perfect square root, but I'm going to go ahead and round to the hundredths place. So sometimes we have to find the length of the hypotenuse, and sometimes, like in this one, problem 2, we have to find the length of a leg. I do apologize that this 5 got cut off, so the one leg of the triangle is 5 centimeters. So I've got my formula once again, a squared plus b squared equals c squared. So a is 5, b is my unknown, and c is 13. 25 plus b squared equals 169. I need to subtract 25 from both sides. B squared equals 144, which means that my length of B is 12. Once you recognize the formula, you can just plug things in and solve for the variable. So as we take a look here, there is a got it question, and it is not on your notes paper. If you feel like you need to try a question, and I do recommend it, but if you'd like to try this question, please go ahead. Pause your video, give it a try just in the margin or somewhere on scrap paper, and see if this all makes sense. All right, welcome back. If you solved this question, the answer should have been 9. If that does not make sense to you, please pause your video and raise your hand or ask for help. Something else that we need to be able to do is identify if something is a right triangle. So if something is a right triangle, then the Pythagorean theorem will always work. So again, the formula a squared plus b squared equals c squared. So if I am trying to figure this out, I see 6, 24, and 25. And one question that I usually get is, how do I know which one is side C? Side C, like I mentioned previously, is always the longest side. So 25 is going to be my C. A and B, it does not matter which is which. So 6 squared plus 24 squared equals 25 squared. And in order to see if these are right triangles, I'm going to see if this works out correctly. So 36 plus 576 is that equal to 625? And the answer is no. I have 612 equals 625, so this letter A is not a right triangle. So the same for problem B. I'm going to have A, B, and C. Once again, being able to tell that that is side C, specifically because it is the longest. 4 squared plus 8 squared equals 10 squared. 16 plus 64 equals 100. 80 equals 100, which is once again not true, so this is not a right triangle. In order for it to be a right triangle, it would need to be something like 100 equals 100, or the same thing on both sides. So go ahead and pause your video and try C and D and see if they are or are not right triangles. And when you're ready to check your answer, please resume. All right, welcome back. So as you did letter C and D, in letter C, you should have gotten 676 is equal to 676. So letter C is a right triangle. In letter D, you should have gotten 289 equals 256. So letter D was not a right triangle. Once again, if any of this does not make sense, please make sure you pause your video and ask for help. So now, moving on here, we've got some vocabulary here. A radical expression is an expression that contains a radical or a square root symbol. A radical expression is simplified if the following statements are true. The radicand, the number inside the square root, has no perfect square factors other than 1. The radicand contains no fractions, and no radicals appear in the denominator of a fraction. So we have in our notes here, on the left side we've got our simplified radical expression. So 3 square root of 5, 9 square root of x, and square root of 2 over 4 are simplified. The not simplified ones do not follow the statements as being completely simplified. 3 square root 12, square root of x over 2, and 5 over square root of 7. We've got a radical number in the denominator. We have 12, which has more factors than just 1 in itself. And when we have square root of x over 2, we do also have a radical in the denominator once again. So we need to be able to simplify these things, and this will connect back to our Pythagorean theorem as well as how we simplify. So when we have some square roots, one thing to notice is that when you have something like the square root of 48 over there in the example, we can split that up into a multiplication problem so that we can take the square root of part of those values, of the factors. And so 48 is the same as 16 times 3, and we do know the square root of 16 is 4. So that actually simplifies to 4 times the square root of 3. So let's take a look at what that looks like. Square root of 160. As I'm looking at that, I am trying to figure out what are factors of 160 when there is for sure a perfect square root, or a perfect square, as one of my factors. So when I'm looking at 160, I am looking for factors. So I can divide by 2, I can divide by other values, but as I start to look at that, I think that I can also divide by 10. And when I divide by 10, I end up with the square root of 16 times 10. So those are my two factors. So you can write it like this, or 16 and 10 separately like that. Now, 16 times 10 does still give me that 160, but I can simplify one of those square roots. Square root of 16 is a perfect square and simplifies to 4. So now I have 4 radical 10, or 4 square root of 10. As I look at this, I think about the number 10 just to make sure I don't have any other perfect square roots that I can factor out. 1 times 10, neither of those are perfect squares. 2 times 5, neither are perfect squares. And so at this point, this is my most simplified version of the square root of 160. So take a look at this got it question. You've got the square root of 72. Please pause your video, give this question a try, and resume when you are done. All right, welcome back. Here is the answer, the square root of 72. So, the square root of 72, I'm sorry, the simplified version is 6 square root of 2. So, if you have questions about how we got that, please pause your video and raise your hand and we can help you. So, what happens when we throw a variable into there? So, when I have square root of 54 n to the 7th, I am trying to, again, simplify as much as possible. So, if I start with just the number 54, 54 is the same as the square root of 9 times 6, because 9 times 6 is 54. And then if I think about my n's, n to the 6th and n to the power of 1, or just n. When I look at my first set here, square root of 9 is 3, so I end up with 3 in the square root of 6. I'm going to leave myself some space there. 3 in the square root of 6. Now, when I take the square root of n to the 6th, I need to remember that I am looking for what times itself would get me back to what's inside my square root. So n to the 3rd times n to the 3rd is what I am looking for here, because when I take that times itself, I do add the exponents to get me to n to the 6th. Now, I pull that singular n, or I leave that singular n inside my radical symbol because I cannot find the square root of that. So a little tip as you are looking at variable factors, you are not going to be able to pull out the square root of a variable with an exponent when the exponent is odd. So you want to look at making that even when you split it so that you can, in fact, split it up into its square root. So go ahead and take a look here at the got it. Notice there is a value in front. So focus first on what is inside, and then remember that this is a multiplication problem. The whole thing is. And so as you do this, just kind of keep that in mind and see how it goes. All right, welcome back. If you are not ready for your answer, please pause. But the answer for got it for 5 is negative 4m to the 5th times the square root of 5m. So if you have questions about this one, and especially this one, if this does not make sense to you, please make sure you pause and ask for help, and we are more than happy to help you. Take a look at got it 6. So when you are looking at, not got it, but problem 6. When you're looking at problem 6, this is one big multiplication problem. 2 times the square root of 7t times 3 times the square root of 14t squared. So I'm going to rearrange this multiplication problem because I know because of the commutative property that I am allowed to do that. And I'm going to go ahead and multiply 2 times 3, and that equals 6. And then I'm going to go ahead and multiply what is in my parentheses. So I'm going to multiply 7t times 14t squared, 7t times 14t squared. 7 times 14 is 98. T squared times t is t to the 3rd. So now I have this. However, this is not my most simplified form. So I'm looking at what can I divide 98 by that will give me a perfect square root. So 98 divided by 2. 98 divided by 2 is actually 49. So now I've got 6, the square root of 49 times 2. And then again, I want to make my t an even number so that I can find the square root. I can now simplify. The square root of 49 is 7, so I'm going to have 6 times 7 on the outside of my radical. My 2 is going to have to stay on the inside. It does not have a perfect square root. T squared, the square root of that is plain t. And t does not have a perfect square answer, so I am going to leave it inside the radical. At this point, again, to simplify, I can just go ahead and take that 6 times 7, so my answer is 42t times the square root of 2t. Please go ahead and take a look at the got it. You do have 2 got it questions here, and if you have a question or need some more help before, please again raise your hand. Otherwise, pause and solve, and when you're ready to check your answers, resume your video. All right, welcome back. So here are your answers. We've got 3a squared times the square root of 2 for the first one, and 210x cubed for the second one. The second one, it does not have a square root in it anymore. Again, if you have questions, please make sure you raise your hand and ask. So one of the things that we need to know is that when we are looking at square roots of a fraction, the square root of the entire fraction is the same as taking the square root symbol and isolating it to just the top and just the bottom. So looking at it separately instead of as one whole piece. So if we take a look at this, in problem A, square root of 64 over 49 is the same as writing square root 64 over square root 49, which gives us 8 over 7. Now, in letter B, I am going to have to erase this, so I apologize for that. But in letter B, one thing that I do want to point out is that sometimes, and you will start to see when, but sometimes it is helpful to simplify the fraction. So if I look at 8 over 50, and I have x cubed over x, I can divide the 8 and the 50 both by 2. So I'm going to go ahead and do that. 8 divided by 2 is 4. 50 divided by 2 is 25. And as you can see, when I simplified in this specific problem, it gave me 2 perfect square roots, which is going to make my problem go a lot easier. X cubed over x, I know because of exponent rules that when I have a division problem, I subtract. So x cubed minus x to the first is x squared, and that goes in my numerator. So as I look here now, I have the square root of 4x squared over the square root of 25 is going to give me 2x over 5. Now, if you were to go ahead and start with your square root of x cubed, 8x cubed over 50x, you can individually square root them and start going that way, but it does get a little bit more complicated. So I would encourage you to at least take a look at simplifying first and see if that will help you out. All right, go ahead and take a look at this. Got it? Again, if you have questions, raise your hand. Otherwise, pause your video, give these a try, and when you're ready to check, resume your video. All right, welcome back. So here are the answers. 4 for letter A, for letter B, 3 over A, and for letter C, 5y times the square root of y, all of that over z. Once again, if this does not make sense, if you're not sure where we got these answers, please make sure you ask. And that is it for our lesson today. So I hope that after this lesson you have a better understanding of Pythagorean theorem and of simplifying radicals. Please show me your notes to show that you've completed this lesson, and you will receive the assignment.